All right, let's talk about how the internet actually works. I mean, really works. Forget all the technical jargon for a second because we're going to break down the backbone of all digital communication using a really simple idea, the Global Postal Service. Let's dive in. So, imagine you have this huge 20-volume set of encyclopedias, and your job is to ship it halfway across the world. The catch? Every single volume, every single page has to get there in perfect condition and in exactly the right order. It's a bit more complicated than just dropping it in a mailbox, right?
I mean, think about all the things that could go wrong. Some volumes could just vanish into thin air. They could take totally different routes and show up completely jumbled. Volume 15 arrives first, then 3, then 8. A total mess. Pages could get ripped. Heck, what if the person on the other end can't even read the language it's written in? And maybe the biggest question of all is, where do you even begin? This physical problem? This is exactly what the internet has to solve for your data every single second of every day.
To solve this massive encyclopedia puzzle, you'd really need two things. First, you need a universal rulebook that everyone involved agrees on, from how to pack the boxes to how to write the address. And second, you need a dependable delivery network to actually get those boxes from point A to point B. And guess what? The internet is built on those exact same two ideas. So, let's start with that rulebook. In the world of networking, we call this a layered architecture. Just think of it as a standardized 7-step checklist for sending any piece of information, making absolutely sure it can be understood and put back together perfectly on the other side. So, this official 7-step guide is called the OSI model. Now, instead of just memorizing the names, let's think about them in terms of the job they do. At the very top, you have the layers that get the message ready. The application layer, that's you writing the content of the encyclopedia. Then the presentation layer translates it, maybe encrypts it. And the session layer, well, that's like making the phone call to say, hey, I'm sending you something. Then you get to the logistics. The transport layer is so important. This is where we chop that massive encyclopedia into smaller, numbered volumes. And the network layer is what slaps the final international address on each of those volumes. And finally, you've got the layers that handle the actual physical trip. The data link layer puts the address of just the very next post office on the package. And the physical layer? That's the truck, the plane, the wires. It's what actually moves the bits.
And this whole process has a really cool name, encapsulation. As your data travels down through those 7 steps, each layer wraps it in its own little package with its own label. Your data gets put into a packet with the final address, which then gets put into something called a frame with the next hop address. It's literally like putting a letter inside a local envelope and then putting that envelope inside a big international shipping crate.
Now, that 7-layer OSI model we just walked through, it's the official textbook version. It's absolutely perfect for understanding every single little job that needs to happen. But in the real world, the internet we actually use runs on a slightly more practical, streamlined version of that rulebook. So here's how the theory stacks up against reality. This is the TCP IP model, the one that actually powers the internet. And you'll notice right away, those top 3 layers, application, presentation, and session, they all get squished together into one single application layer. And why? Well, because in the real world, your web browser or email app does all of that stuff at once. It creates the data, formats it, and manages the connection. The rest of the layers match up pretty perfectly. The big takeaway is that the logic is the same. Break a huge problem into smaller steps. It's just been optimized for pure real-world efficiency.
Okay, so we've got our rulebook. We know exactly how to pack and label every single volume of our encyclopedia. Now we need that second piece we talked about, the delivery network. This is all about how those packages actually travel from you to their final destination.
And there are really 2 main ways to do this. The first is called circuit switching. The best analogy for this is chartering your own private cargo plane. You set up one dedicated path from start to finish, and that path is reserved only for you. No one else can use it. The second way, which is what the internet is mostly built on, is packet switching. This is just like using the standard mail. Every single package or packet is sent on its own. They all get thrown into the system and might take completely different routes to get to the same place.
And when you put them side by side like this, you really see the trade-off. Circuit switching is all about guaranteed reliability. You get a dedicated path, everything arrives in order. It sounds great, but the downside is, if you're not sending anything, your private plane is flying empty and you're wasting a ton of bandwidth. Packet switching, on the other hand, is all about efficiency. It makes sure the network's roads are always being used by someone. The trade-off? Well, your packages might show up out of order, and it's up to the system to put them all back together correctly.
So you've got this one extreme, the super reliable but potentially wasteful private plane, and the other, the super efficient but chaotic postal service. Naturally, people thought, isn't there a middle ground? And there is. It's called a virtual circuit. This is kind of like booking a reserved spot on the same cargo flight every single day. You don't own the whole plane, but all your packages follow the same logical path, giving you a bit of that reliability while still being flexible.
Okay, but why are we getting so deep into these delivery methods? Circuit, packet, who cares, right? Well, it matters a ton because the method you choose has a direct and totally calculable impact on how fast your data gets where it's going.
When you think about the total time it takes for a message to arrive, the math is really different. With circuit switching, you have this one-time delay right at the start to set up the connection. That's the time it takes to book your private plane. But after that, it's a direct flight. With packet switching, there's no setup time. You just start sending. But each individual package might hit a little bit of traffic at every post office or hop along the way. So you have to make a choice. Do you want a bigger delay up front for a guaranteed clear path? Or do you want to start instantly but risk lots of little, unpredictable delays along the way?
And that really brings us full circle. Every single time you send an email, load a website, or watch a movie online, this is what's happening behind the scenes. Your message is the encyclopedia. The layers are the universal rulebook for chopping it up and labeling it. And packet switching is that incredible global postal service that routes all those millions of tiny pieces all over the world, only to have them reassembled perfectly on the other side.
So I'll leave you with this to think about. If every single thing you do online, every click, every message, is actually being shattered into thousands, maybe millions of tiny pieces sent on completely different journeys across the planet, and then reassembled in fractions of a second, how on earth does it all feel so smooth and instantaneous? It's pretty amazing when you think about it. It's the magic of this incredibly complex, yet beautifully logical system.